The Solar Vehicles team is a group of engineering students who throughout the year build a car that's run entirely off of solar power and then compete in 2 events over the summer. As lead mechanical, I'm responsible for designing and overseeing the manufacture of the chassis, suspension, steering, and braking systems. My biggest accomplishment on the team is redesigning and machining the rear tire mount under an intense time constraint. During inspections, it was found that the rear tire had 27 more kilograms on it than it was weighted for. Ordinarily, it would have been easy just to buy a bigger tire rated for a higher load, and then slide it back on the swing arm to prevent it from running into the supports in the back. However, the brake caliper mount is welded to the swing arm. Therefore, if we were to move the tire back a couple of inches, the calipers would no longer grip onto the brake disc, and we would lose our rear brakes and our parking brake. As a result, I had to design, perform finite element analysis on, and machine an extension to the caliper mount, which would be the new place on which the calipers were mounted so that they could grip the brake disc. The extender had to allow the calipers to be mounted on the same plane that they were originally positioned in, or they wouldn't align correctly. Thus, the thickness of the plate had to be cut halfway through in the shape of the existing mount so that it could fit snugly next to it. It also had to be cut halfway through on the other side in the shape of the calipers so that it could remain on the same plane as the original position.
I know it's definitely not the prettiest machining I've ever done, and the pieces could be a lot more lightweight than they are, but I'm still proud of this work. I had 2 days to complete the task. The first night I designed the parts and made one of them on a manual milling machine. The next day I spent all day at the track to help the car get through the rest of the inspections. The second night I made the part for the second brake, tapped the holes, mounted both pieces to the car, and fixed the brakes onto the extenders. The next day we passed inspections, completed dynamic testing, and had the go-ahead to start racing the next morning. When I'm not working on the solar car, I'm making my own rockets through the Longhorn Rocketry Association. 3D printing rocket nozzle molds, making nozzles, attempting to make my own motors, doing research on white dwarf stars at McDonald Observatory, doing research on gold and silver nanoparticles, disassembling satellites at Texas Spacecraft Laboratories, machining, and working on other projects for myself.